Hey guys, and welcome back. This is one video on basic trig functions, common angle, and also the unit circle. So let's go. Hey guys, and welcome back to your channel. This is Franck, and if you have not done so already, go ahead and subscribe to the channel so you can get more videos like this one. Today, we are going to be covering basic trigonometric functions and common angles. So I'm going to use the unit circle here to show you a way to memorize all the common angles value and their output when they go to the functions. And so, when it comes to basic trig functions, I'm going to have three of them and the reciprocal. And so by this point, you should already be aware of it. If you had a rectangular triangle like this one, with the side here as A, B, and C for the longest side, the angle theta here formed by the longest side C and the adjacent side B can be an input for our basic trig functions. And so in this scenario, the sine of theta is going to be equal to the opposite side over the hypotenuse, which is going to be, in this case, A divided by C. And your cosine, the cosine of theta, is going to be equal to the adjacent side divided by the hypotenuse, which in this case is going to be B divided by C. And of course, here you're going to also have the basic trig function tangent, which, as you know, the tangent of theta is going to be equal to the sine of theta divided by the cosine of theta, which in this case is going to be A over C divided by B over C. And so if you go ahead and simplify this, you're going to get A over C multiplied by the reciprocal of the second fraction, which in this case is going to be C divided by B. And so with that, you're going to have the C cancel each other out. And finally, you're going to get A over B. So the tangent of theta here is directly equal to the opposite side A over the adjacent side B. All right, so these are my three basic trigonometric functions. And now let's talk about the reciprocal. So for the sine of theta, the reciprocal here is going to be the cosecant of theta, which is simply going to be equal to 1 over the sine of theta, which in this case would be equal to C over A. So that's going to be the hypotenuse over the opposite side. And the reciprocal of cosine is going to be the secant. And so for the secant of theta, we're going to have that equal to 1 over the cosine of theta, which is going to be equal to C over B, which is the hypotenuse over the adjacent side. And finally, the cotangent of theta is going to be equal to the reciprocal of the tangent, which is going to be 1 over tangent theta, which is going to be equal to cosine divided by sine instead of sine divided by cosine, which in this case then is going to be B over A instead of A over B. And so in this case, we're going to have the cotangent of theta equals to the adjacent side divided by the opposite side. All right, so with that in mind, let me go ahead and give you all the common angle. So to do that, I'm going to go ahead and draw the unit circle here. So I have my circle here, and then I'm going to have my axis here. So I'm going to have the x-axis here and the y-axis here. This is the unit circle, so it cuts the x-axis and the y-axis here at 1 and 1. And the x-axis here is going to correspond to the cosine of theta, while the y-axis here is going to correspond to the sine of theta. And so with that, since we already know that a full circle corresponds to 2 pi in radian, which is the same thing as 360 degrees. And so if you were to divide this whole circle into 12 pieces, one of the pieces will be equal to 360 degrees divided by 12, which is the same thing as 30 degrees. In radian, that is equal to 2 pi over 12, which is the same thing as pi over 6. And so knowing that, you can go ahead and fill out what all the other angles are just by counting them out. And so at the very beginning here is going to be 0 pi over 6, which is basically 0. And then we're going to have 1 pi over 6, which is pi over 6. And then next we're going to have 2 pi over 6, which can be also written as pi over 3 if you simplify it out. The next one here on top is going to be 3 pi over 6, which can be written as pi over 2. Next, we're going to have 4 pi over 6, which is also equal to 2 pi over 3. Next, 5 pi over 6. And then 6 pi over 6, which is the same thing as pi. Then we have 7 pi over 6. Next, 8 pi over 6, which is the same thing as 4 pi over 3. Next, 9 pi over 6, which is the same thing as 3 pi over 2. Next, you have 10 pi over 6, which can be simplified as 5 pi over 3. Then you have 11 pi over 6. And finally, 12 pi over 6, which is the same thing as 2 pi, which also corresponds to just 0, because 0 and 2 pi are coterminal angle. And we are going to talk about coterminal angle in my next video, so look out for that one. Alright, so these are some of my common angles here, and I obtained them by dividing the whole circle by 12. But there are also some other common angles going in between some of these angles, and you can obtain them if you go ahead and divide the whole circle in 8 pieces. And so with this, dividing the whole circle in 8 pieces would make the angle of one of the p's be equal to 2 pi over 8, which is the same thing as pi over 4. And so in this case, I'm going to go ahead and count again to have all of my angles. And so my first angle here, of course, is the 0. Then I'm going to have pi over 4 right here. Then I'm going to have 2 pi over 4 up here, which is the same thing as pi over 2, so I got it already. Then I'm going to have 3 pi over 4. Then 4 pi over 4, which is the same thing as pi, so I've already got it. Then I'm going to have 5 pi over 4. Then I'm going to have 6 pi over 4, which is the same thing as 3 pi over 2, so I already got it. Then I'm going to have 7 pi over 4. And finally, 8 pi over 4, which is the same thing as 2 pi, which is the same as just being 0. And so with this, these are all the common angle on the unit circle. But usually, when you learn about common angle, you're only going to be focusing on the first 5 right here, which are 0, pi over 6, pi over 4, pi over 3, and pi over 2. Because if you know the value of these angles as far as the basic trig functions goes, you can figure out the value of all the other angles. And so what I'm going to show you now is a quick and easy way to remember what the cosine and sine of these basic angles are. So let's go ahead and start with the sine function right here. And so with these 5 angles here, you're going to go ahead and have them hit the sine axis so that we can read off what the corresponding sine values are. And so the first thing you're going to do here is go ahead and just count them out, starting with 0. And so you're going to have here on the bottom 0, then 1, 2, 3, 4. And then next, you can go ahead and put the square root on each of those numbers. And finally, you can go ahead and divide all of them by 2. All right, and so after that's done, you can just go ahead and read out what the sine of those angles are. And so you're going to have here that the sine of 0 is going to be 0. The sine of pi over 6 is going to be the square root of 1 over 2, which is the same thing as 1/2. The sine of pi over 4 is going to be the square root of 2 over 2. The sine of pi over 3 is going to be the square root of 3 over 2. And finally, the sine of pi over 2 is going to be the square root of 4 over 2, which the square root of 4 here is 2, so 2 divided by 2 will give you just 1. With that, you can go ahead and do the same thing with the cosine. So you can go ahead and bring the angles down here so you can read up what the cosine are. Then you go ahead and count them out. So you're going to have 0, 1, 2, 3, 4. Finally, you can go ahead and put the square root on each of those guys while dividing them by 2. And so with that, you can also go ahead and say that the cosine of 0 is going to be here, the square root of 4 divided by 2, which is the same thing as 1. Then the cosine of pi over 6 is going to be the square root of 3 over 2. Then the cosine of pi over 4 will be the root 2 over 2. Cosine of pi over 3, that's root 1 over 2, which is the same thing as 1/2. And finally, the cosine of pi over 2 is going to be the square root of 0 over 2, which is just 0. Okay, so once you have the sine and cosine, you can go ahead and fill the rest of this table without needing the circle anymore. And so we know that tangent is equal to sine over cosine, so the tangent of 0 here is going to be 0 divided by 1, which is 0. The tangent of pi over 6 is going to be 1/2 divided by the square root of 3 over 2. Since the 2 and 2 are going to cancel, all you're going to have is 1 over the square root of 3. Tangent of pi over 4 is going to be 1, because that's the square root of 2 over 2 divided by the square root of 2 over 2, same number. Tangent of pi over 3 is going to be the square root of 3, because the 2 would cancel here, and you're going to get square root of 3 over 1. And finally, the tangent of pi over 2 is going to be 1 over 0, which doesn't exist because you can't divide the number by 0. With that, you can also figure out what the cosecant is, because that's going to be the reciprocal of the sine function. And so we're going to have here for the first one, 1 over 0, which doesn't exist. Then the next one here is going to be the reciprocal of 1/2, which is 2. Then you're going to have 2 divided by the square root of 2. Then 2 divided by the square root of 3. Then 1. And for the secant, we're going to have the reciprocal of the cosine function. That's going to give us 1. Then 2 over the square root of 3. Then 2 over the square root of 2. Then 2. Then 1 over 0, which doesn't exist. Finally, the cotangent is going to be equal to 1 over the tangent. And so the first one here is not going to exist because that's 1 over 0. Next one here is going to be square root of 3, then 1, then 1 over the square root of 3, And finally, for this one here, you're going to have the cotangent being the cosine over the sine. And so that's going to be 0 over 1, which gives you 0. All right, so with that, let me go ahead and show you how you would find the value of some basic trig functions for any other angles other than these 5. So the first example that I have here is going to be how to find the cosine of 2 pi over 3. And so since the angle 2 pi over 3 is right here, you can see that the cosine of 2 pi over 3 will be the same as the cosine of pi over 3, but only with a different sign. And so in this case, the answer is not going to be 1/2, but negative 1/2, and you're done. And so next, how would you find the cosine of 5 pi over 6? You're going to do it the same exact way. You're going to notice that the angle 5 pi over 6 and the angle pi over 6 have the same value for cosine, but with different sign. So in this case, you're going to have that the cosine of 5 pi over 6 is going to be the square root of 3 over 2, but negative. And by the way, pi over 6 here is what is known as the reference angle for 5 pi over 6, and also pi over 3 above here is what's known as the reference angle for 2 pi over 3. And so if you want to know about reference angle and how to find them, I suggest you check out my next video where I'm going to talk about that in detail. Next, how would you find the sine of 3 pi over 2? Okay, so 3 pi over 2 is right in the bottom here, and so that's going to be opposite to pi over 2, that's all the way up here. And so we're going to have that the sine of 3 pi over 2 is just negative 1. All right, so next, how would you find the tangent of pi? And so in this case, the tangent of pi here is going to be equal to the sine of pi divided by the cosine of pi. And as you can see here, the sine of pi here is going to be 0, while the cosine of pi is going to be negative 1 because it's on the other side here. And so with that, you're going to get that the tangent of pi is just 0. Next example, how would you find the cosecant of 7 pi over 6? So first of all, we should know the cosecant is the reciprocal of the sine function. And so since the sine of 7 pi over 6 and the sine of pi over 6 here have the same value but different sign, you're going to have the negative reciprocal of that being equal to negative 1 divided by 1 over 2. And so simplifying that should give you negative 2. So the negative here is coming from the fact that they are on opposite side, and the reciprocal here is coming from the fact that the cosecant and sine are reciprocal. Next, how would you find the secant of 11 pi over 6? First, you're going to notice that 11 pi over 6 and pi over 6 have the same values, since the secant is the reciprocal of the cosine, and so you're going to have that equal to the secant of pi over 6, which is going to be equal to the reciprocal of root 3 over 2, which happens to be 2 divided by root 3. And if you're the kind of person who likes to rationalize things, you're going to have to multiply both numerator and denominator by root 3, and that's going to give you 2 root 3 divided by 3. Finally, how would you figure out the cotangent of 3 pi over 4? 3 pi over 4 can be found over here. And so with that, knowing that the cotangent is simply equal to the cosine divided by the sine, you're going to have that equal to the cosine of 3 pi over 4 divided by the sine of 3 pi over 4. And so the cosine of 3 pi over 4 here is the same as the cosine of pi over 4, but different sign. So you're going to have on top negative root 2 over 2. And the sine of 3 pi over 4 is the exact same as the sine of pi over 4. And so you're going to have on the bottom here root 2 over 2. And that together should give you negative 1. And so with that, we are done. And as always, if you would like a free copy of this particular note, check out the description below. And if you like the way I break down the material, give me a thumbs up, and I'll see you next time. Bye-bye.